Hey, everybody. Thank you for joining today's KVA. I am Tom Fitzgerald. Today, we are going to be talking about something I'm very excited about, something I've been thinking about for quite some time now, really around how do we go about transitioning from a 2D design workflow to 3D design? You know, what kind of things are involved with transitioning from 2D design to 3D design? So we're going to be going over a lot of things over the next hour, as well as getting into this series around transitioning from 2D to 3D. Like I said before, super excited about this topic. Everybody should know me by now. Tom Fitzgerald, Senior Technical Solutions Executive here at KETIV. Been with KETIV for about 3 years. Previous to that, I was a solution architect at Autodesk, servicing our manufacturing customers in very much the same way as I'm doing here at KETIV. Been within the 3D design industry for over 25 years now, as well as over 30 years of manufacturing industry experience. I'm also a U.S. Army veteran, and in my free time, I study World War II history. So let's get into today's topic about transitioning from 2D to 3D. So like I said before, this is going to be a 4-part series. We have 4 different episodes. We're going to break it down in such a way where you guys get a lot of value out of the content, as well as being able to really identify the areas that you need to be focusing on when you're transitioning from 2D to 3D. So this first episode, we're going to be talking about how to plan and prepare for your transition process. How do we go from utilizing 2D design information and then creating and leveraging 3D design information? So that's really the context as to what we're going to be talking about over these next 4 episodes. So very progressive, very linear process in terms of what we're going to be talking about within this webinar series. The first one, like I indicated, we're going to be talking about how to prepare and plan for your transition. We're going to be defining who, what, where, when, and how are we going to be going through this process. Our next episode, which I hope that you join us for, is going to be about how do we develop 3D content. If you're very used to using 2D information, developing AutoCAD drawings or flat 2D, two-dimensional drawings, how do we go about transitioning and creating content so that way we have some sort of foundation around our 3D design development? From there, how do we develop the workflows as necessary? What should we be looking at in terms of altering or modifying our workflows to take advantage of those strengths that a 3D design application like Inventor is going to be able to provide us? Once we have all that, preparing, planning, creating content, developing our workflows, what comes next? What is after all that? What is beyond the horizon in terms of what can we leverage from our 3D design tool? And that's really around automation and integration of different systems to kind of streamline that process. So these are the things that we're going to be talking about over this 4-part series, okay? So first thing I want to ask everybody is I have a poll here. I want to understand, what is your current 2D to 3D transition state? Meaning, where are you along this journey? You're just kind of looking into and investigating 3D, or are you currently in the process of transitioning from 2D to 3D? Maybe you've already transitioned to 3D and you just like to get a little bit more insight as to maybe where some of these challenges might exist that you're experiencing. Or maybe you've already done it and you just like looking at me and like hearing some of the things that I have to say. So please go ahead and answer this poll, and we'll review the answers at the end of the webinar today. All right? Right. All right. Now that that poll is completed, let's go on to our next slide here. So I really want to point out to everybody, I'm sure everybody who's been joining these KVAs in the past knows pretty much who KETIV is. But if you're new, if this topic is interesting to you and want to know a little bit more about KETIV, well, this slide right here kind of illustrates a little bit more as to what we do here at KETIV, right? When it comes to working with our manufacturing customers around developing sales and estimating tools or processes, or from working with the CAD and design tools like AutoCAD and Inventor, to leveraging some of our simulation and analysis tools like, say, ANSYS, to be able to then go further down the line in terms of our manufacturing process and understanding what more can we do around advanced manufacturing, like additive manufacturing or subtractive manufacturing. Underneath all that, you'll notice that we have this thread of data management that kind of weaves its way through all those different areas. So here at KETIV, we focus on all of these things. What do you need from a manufacturer's perspective in order to do what you do better and easier and obviously make more money? So that's what we're here for. So that's a little bit about KETIV. Today's episode, planning and preparing for your 2D to 3D transition. So we want to talk a little bit about the history of CAD. Does everybody even know what CAD means? 2D versus 3D. Why is there a difference? What is the difference there? And of course, what are the benefits of transitioning to 3D? Why should we change at all? So we're going to want to talk a little bit about the benefits of 3D. From there, we're going to do a little bit of a demonstration, kind of show off some of the things around those benefits of Inventor and 3D CAD. And then we'll get into, well, what should we do around preparing for our transition when it comes to licensing, to training, to what can you do internally to alleviate some of the complications and pitfalls that we experience from going through this transition? How should we be organizing our files and focusing on developing different naming conventions, and why might this even be important? Focusing on your data consumption needs, understanding what it is from an engineering perspective around the data that engineer needs, as well as other areas within our manufacturing business. What information do they need from engineering? So how is this data being consumed? And then we want to talk a little bit about metadata. And if you're new to 3D design, and if you're trying to get a little bit of information around the process of transitioning from 2D to 3D, understanding words like metadata and properties and attributes are going to be extremely important. So we want to talk about metadata for a little bit when we're focusing on our planning and preparation from 2D to 3D design. All right. So history of computer-aided design, CAD, computer-aided design, right? So the first CAD application was developed in 1961. So you got to go way back in the time machine to see Sketchpad for the first time in 1961. Very arbitrary, very simplistic application in terms of being able to draw graphical representations of lines, arcs, and circles. So really rudimentary, that first CAD application way back in 1961. The evolution of CAD from there starts tacking on additional functionality as, computer hardware starts in becoming more capable, as we start understanding more around interconnection of systems and developing how do we communicate between different computers. So the rendering capabilities around CAD, being able to apply surfaces and textures and things along those lines, really didn't start come into introduction until the 1970s. So if you think about the 1960s, if you look behind me, in the 1960s, this is what we were doing in the 1960s, is building big rockets like this without the assistance of a lot of computers, without the assistance of computer-aided design, to do mathematical calculations to that extent, to be able to build very highly complex machinery without the need of some of these CAD applications. It wasn't until the 70s that really that started ramping up. Our friends in France, Dassault, introduces CATIA in 1977. Those of you that are familiar with CAD should be familiar with CATIA. It's a very high-end CAD application, and as you can see, it's been around for quite some time. In the 1980s, IBM introduces the personal computer, as we all know, and in 1983, AutoCAD comes out very much right after the personal computer. So AutoCAD, so being able to start using a computer to represent those lines and circles in such a way that we can start conveying information around how something might be manufactured. Okay. In 1988, our friends at John Deere become the first users of Pro-E. So PTC, a company that developed a CAD application called Pro-E. John Deere is the first company to start using Pro-E in 1988. In 1997, so now we're in the mid-90s, we're all familiar with Windows operating systems by this point. Computers, PCs are in almost everybody's home by this point. The internet is starting to pick up traction. And now we start seeing some of the more familiar names around CAD being introduced in the mid to late 90s. Dassault acquires SolidWorks and then distributes SolidWorks back in the late 1990s. And then in 1999, Autodesk comes out with their first true 3D parametric design application called Inventor. So for about the last 25 years now, or give or take, we've had the luxury of having very user-friendly CAD applications at our disposal to use within manufacturing. So it's a little bit of background in terms of the history of computer-aided design. The little image here, this image in the PowerPoint comes from the 1960s. So imagine using a computer like that in the 1960s to do the work that you do today. Would be very challenging to say the least. All right. So this is the evolutionary step of around drafting and design. Before the 1960s, before the 1970s, really, everything was done on a drafting board. You had a paper, you had pencils, you had some sort of straight edge and some other tools in order to manually create these designs and this information for manufacturing. Computer-aided design is a natural step in terms of evolution. It's basically a drafting board, but now we're using computers to do the same thing, right? So this is your AutoCAD. This is your any of your other traditional two-dimensional design tools, right? Where you're creating lines, you're creating arcs, you're creating circles, rectangles, you're putting them together, representative of a design. Now, 3D design is a departure from all of that. We're not using a drafting board. We're not too worried about that layout, that 2D planar perspective in terms of what we're working with. We're working with things that we can pan, zoom, rotate. We can look at it various ways to start visualizing that information as opposed to having to interpret it. So the evolutionary step of CAD represented here in this PowerPoint slide. What are the benefits? What is the difference, rather, between 2D design and 3D design? So just some bullet points here highlighting some of those variances between 2D design and 3D design. 2D, very plane-based dimensional views to represent objects, right? We got elevation views, we got other isometric views, we got plan views, we got all sorts of different views that are within our drawings in order for us to be able to start interpreting that information. Very sequential linear design process. Typically, depending on the user, there's a lot of interpretation that must occur, right? If you're not used to understanding the differences between line weights, line types, different layers within 2D design, being able to understand what's actually going on with these views can be extremely challenging, particularly if you're new. It usually takes a lot of time to understand how to interpret some of these two-dimensional drawings. There's a lot of opportunities for errors when working with 2D design tools. Imagine whatever it is that you do in terms of manufacturing, and you have to make a change to the design. Typically, you have to go to many different sheets, many different views, update those sheets and views, and make sure that you don't miss something. So there's a lot of potentiality for mistakes to be made when working with 2D design as well. And there's typically some training that's required for traditional manufacturing. And what this really means, is if you want to understand traditional or if you want to understand traditional manufacturing, it's very easy to pick up 2D design for those manufacturing practices. Whereas within 3D design, right, we're working with volume-based 3-dimensional objects as opposed to those 2-dimensional objects. In terms of its development process, it's very iterative rather, meaning you can do a little bit of work and then you can come back and add to it or remove from it. Allows for a lot of flexibility in terms of your design process. When working within 3D design, in most instances, you have all the information that you need right there within your particular data set. So a lot of comprehensive data associated to that one data set, so that way you can start pulling a bunch of different information as necessary. Within 3D design tools, we have the opportunity to do validation, simulation, analysis, error checking, clash detection. So a lot of these challenges that we're typically faced with 2D design naturally become solved when you start working within 3D design, because it's inherent to those tools and applications and processes. And in order to use 3D design, you have to have more advanced manufacturing knowledge. A little bit more around CAM, CNC machines, additive manufacturing, right? 3D printing, those types of, that type of knowledge base rather, is going to be really beneficial to understand those things if you're transitioning into 3D design. And in a lot of instances, it's going to be necessary to have some familiarity with those manufacturing processes to really take advantage of the strengths of 3D design as well. All right, so those are some of the differences between 2D design and 3D design. So let's really focus on the benefits of 3D design. So I'm hoping that some of these things here resonate with you in terms of the challenges you're currently facing with working within 2D design. And some of these things might drive you to pay a little bit more attention or have a little bit more enthusiasm around transitioning to 3D design. So some of these benefits really come into play around enhanced visualization. Like I said before, being able to pan, zoom, and rotate to visualize the information in a more intuitive way. Your models are extremely interactive. You can turn things on, turn things off, look at internal components and how they might function. There's the means to rapidly iterate within 3D design. It's very simple and fun in a lot of ways to do, like R&D projects working within 3D design, simply because you can create a design, make a copy of that, and iterate that, and come up with a lot of different design opportunities when working within 3D. Very rapid, and that's really the key there. Is you can do these things in 2D, but they typically take a lot more time, and there's a lot more to take into consideration when you're doing iterations in 2D as opposed to 3D design. There's a parametric element to 3D design, and when I get into the demo here in a moment, I'll highlight that as well, because that's extremely important in terms of how we can optimize our workflows, as we talk about that later on down the road. Direct to manufacturing capability. What this means is, imagine having a machine out on your shop floor that as you develop 3D models, you can feed those 3D models into a manufacturing machine that can directly consume that information. You don't have to worry about outputting specific information in NC code in order for that machine to operate. There's a lot of tools nowadays, a lot of machines and software to drive those machines that can directly consume 3D model information. So if you're thinking about subtractive manufacturing, giving a 3D model to a 5-axis machine, and it knows exactly what to do in terms of whittling away at that billet aluminum or whatever the material might be. So direct to manufacturing capability is definitely a strength of 3D design. You also have opportunities for higher level simulation and analysis. There's some tools inherent to Inventor where as you produce a design, you can do simulation of that design. applying different forces and factors to design to find where specific components may fail or may not fail, or doing a finite element analysis of a bending moment on a plate that might have some force on it. You can start identifying where there may be weak points within your design by using 3D design for simulation and analysis. You get real-time feedback from your design, meaning as you make changes to your design, you automatically get information back at you in terms of maybe when you change a material, how is that going to impact the mass? Or how might it impact the texture of a model or something else? So as you make changes, you get immediate feedback from those changes so you can make decisions to further and refine your design. Reduce development costs. Because of the fact that you're using a 3D design tool, you can do a lot of your prototyping within the digital space as opposed to having to create physical representations and do destructive testing. It's a lot easier to produce integrated documentation. I'll show you that here in the demo as well, how having associations between files to rapidly update information as you make changes in one area, it'll propagate those changes to other areas. Regulatory compliance. Every company I know has to be compliant to one degree or another. By using 3D CAD tools, you have the opportunity to apply standards. You can create rules and logic to enforce design policies to ensure that your designs adhere and meet different regulatory compliance situations. So a lot of benefits in terms of being able to enforce workflows, enforce standards when working with 3D design tools like Inventor. We can work with very complex geometries. Imagine all the consumer goods that are available to us today. Without having 3D design, we wouldn't have a lot of these intricate, aesthetic looking types of products, right? Some of the things that we can do in terms of complex surfaces and blending of surfaces together. We're only capable of doing those types of things because of the fact that we have 3D design tools available to us, right? We've all been hearing a lot about digital twin, that phrase digital twin, and to a lot of different people, it might mean a number of different things. However, without 3D design, you can't even entertain digital twin regardless of how you perceive that phrase meaning to you, right? Without 3D CAD, you can't get digital twin. So if digital twin is something that is interesting to you, reach out to us. We'll give you some more insight around what digital twin really means and how it can benefit you. But just want to point out that in order to start achieving some of these higher technology maturity levels, you want to first get 3D design in place. We have the capability of doing systems integration, being able to tie things together, extracting information from one system and populating that information within our designs so that way our downstream processes can pick up on that information and we can make sure that all our data is accurate and it's formatted appropriately and we're putting good data in and we're getting good data out. So systems integration is very important in terms of achieving that level of optimization. And let's face it, 3D design, it encourages innovation, right? We get people coming out of high school and college right now that are very, very familiar with these design tools. And if you, as a manufacturer, aren't using these tools, well, what kind of talent are you really attracting? These kids that are using these advanced tool sets, simulation analysis, 3D design, automation, systems integration, they're learning these things in high school and college, and they come out and they realize that, you're using tools that are literally 30 years old. Your company may not be as attractive to them as another company. So we got to think about those things as well. And, my favorite thing around 3D design is the fact that we can do automation. So if you want to automate processes, you want to automate capabilities within engineering and design, you got to get to 3D. It's the only way to really achieve it the way that you ultimately want to achieve it. All right. So I hope some of these bullet points resonated with you. So what I want to do next here is I want to get into Inventor and then start showing some of these things, some of these bullet points, so that way you have something to reference against, right? I just still want to put bullet points up on a slide and have you guys use your imagination to realize what this means. But let's look at it here within the context of Inventor as to what a few of these things might be. So first things first, visualization, right? Here I am, I can pan, I can zoom, I can rotate, I can get in there and I can start doing things like right-clicking and doing a simple measurement between this face and this face. Within AutoCAD or a 2D design tool, you'd have to go to the right sheet, you'd have to go to the right view, you'd have to make sure you're clicking on the right entities and hope that that was drawn accurately or one-to-one, so that way your dimension will come out, your measurement will come out accurate, and you're really getting accurate information. Whereas in here within 3D design, I can just simply start selecting on different faces here and get some of that information as necessary. So we have a lot of ways to be able to visualize information. Another one of those things is around analysis, right? So inside of Inventor, we have the capability to do stress analysis and dynamic simulation. I can also do some things like inspect, like I can analyze interference. I can select a couple of different entities here and say, go and analyze any interference that might exist between those two. So now it's doing that computation and it's telling me immediately where there may be some interferences, some general interferences, if there's thread interference or if there's some other non-threaded contents, whatever the case might be. Within 3D design, I have the capability to start understanding if there's clash detection or if there's a collision that I need to be aware of within my design, okay? Some of the other things that we can do here is if I right-click, I can go to my properties of this particular assembly, and I can start getting information from it. What is its part number? What is its description? What is its status, its current status in terms of its design state? I can start getting physical information from this by understanding what is its mass, what is its area, what is its volume, right? So I can get some immediate feedback in terms of some analysis around my design. What are some of these other topics that we were looking at? So visualization. Being able to get some immediate feedback. We can do some advanced analysis of our design. In terms of parametric design, right? So let me drill down into something here, and I'm going to take a look at, not that, but as you can see, just going through this exercise, I have the capability to identify very specific equipment or components that I want to engage with. I want to get more information around, right? So I have this file here. If I open it directly, now I have this handlebar here, and I can do certain things to this handlebar in terms of this sketch here. So if I want to increase the size of this handlebar from 16 inches to say 20 inches, all I got to do is just update a dimension, hit OK. My geometry updates. I save this model. I go back over to my assembly, and here it's automatically updated. So what does this mean? Is I can quickly identify the equipment that I want to update. I can quickly access that information. I can quickly go to a dimension that is driving that geometry, update that dimension. And then wherever that component is being used, it's being propagated throughout those assemblies and updating that information appropriately. So very much like the real world. I mean, if we think about our physical manufacturing process, 3D design really aligns with it more appropriately. If you wanted to make a change to a physical component, well, you'd have to go out to the shop floor and do something in terms of change in the size of the handlebar. But now that that handlebar has been changed and it's now in stock going forward, now that's the component that's going to be used in further designs, right? Future designs. So a lot of capability in terms of being able to visualize. Here, let's just go back up here real quick to this other slide. So that way we're seeing this information. So enhanced visualization, being able to interact with the model, being able to iterate rapidly, to create design changes, parametric design, simulation analysis, we just talked about that, real-time feedback. When it comes to integrated documentation, let's talk about integrated documentation for a moment here. And what I mean by that is inherent to Inventor, we have the capability of associating 2D documentation to our 3D designs. Well, we all know that in order for manufacturing to do what it is that they want to do, those individuals out on the shop floor that are bending sheet metal or fastening things together or welding things together, they can't necessarily solely rely upon the 3D models in order to do their jobs. You know, they need dimensions, they need notes, they need balloons, they need title blocks, they need bill of material, they need all sorts of additional information. And a lot of that information is delivered to them within the context of a drawing, right? So even inside of Inventor, we have the capability of creating drawings. Now, I have a drawing that's already associated to this particular model, but as you can see, here's the drawing that's associated to that model. If I go in here and I make any changes to this model, maybe I only want this to be a 1 base instead of a 2 base. Once I go back over to the drawing automatically updates because it has an association. So what does this mean? Imagine an AutoCAD drawing sheet where it has many different sheets in this one file. In each one of those sheets, it has many, many different views. Here inside of Inventor, I go to the data set, the model data set. I make my changes there. Wherever that data is being used in any of the drawings, on any of the sheets, in any of the views, that data is automatically going to update. So you don't have to go from sheet to sheet to view, making sure that that information is coordinated. You can rest assured that whatever changes you make to that model is going to be reflected appropriately within that drawing. So having an association or integration with documentation that manufacturing needs from engineering, you know, this right here kind of highlights what we can do in that regard. And once again, this is normal, natural Inventor behavior and functionality. There's nothing magical here, that you get this right out of the box. All right, let's go back over to our PowerPoint real quick here. So we touched on a lot of these different things, but just to kind of give you an idea as to the benefits of 3D design, okay? So let's get into the planning and preparation. So you've made your decision. You definitely want to start moving towards 3D. What's the first thing that we got to do? Plan, plan, plan. I've seen way too many companies engage in this activity, thinking that all they got to do is rip out AutoCAD and replace it with Inventor, and everything's going to be hunky-dory. And that's not the case, guys. Inventor and AutoCAD work in totally different from one another. It's an entirely different mindset. It's a different process. It takes different education. They're different tools. Your computers typically need to be different. So it's not just rip out and replace of a tool. It's a rip out and replace of almost everything that you might have to do within engineering. And that might sound scary, but I would rather have you guys well informed and prepared for this undertaking, knowing what you're going to get out at the end, the benefits at the end, than to suggest that this is something very simple, when in all actuality it isn't. But if you do your homework and you do the proper planning, this can go a lot easier than what you might expect. All right. So when it comes to planning, what do we need to be taking into consideration? Well, I highly recommend that you assign some sort of program or project manager. Somebody has to have accountability to this process internally. Somebody has to have visibility to all the moving parts. You can't just rely upon a number of individuals taking on separate, disparate tasks, hoping that at the very end, it all comes together uniformly. And that just won't happen. You have to have that overarching guidance, that individual at the top that understands what it takes to transition to 3D from 2D, as well as having some overarching guidance and accountability to the entire process. Other things you should be taking into consideration: what else is going on within the industry? And what I mean by that is things like artificial intelligence, VR and AR. How are these things impacting? If you have competitors with your industry, what are they doing? How are they benefiting from, transitioning from 2D to 3D? How is it impacting their business? You can always reach out to us. I highly encourage you to reach out to KETIV. If you're interested in transition from 2D to 3D, it never hurts to have a partner that has done this many different times with many different companies and has a lot of exposure to the challenges that a lot of our customers face. So engage with us. We can definitely help you through that process. Identify success measures and your milestones. And that kind of goes with what I'm talking about within this series in terms of your milestones. Planning, how to go through the exercise of planning. That's a milestone. Okay, now we're done with planning. What's the next step? Content creation. Okay, once we're done with that, what's the next step? So make sure you're identifying your milestones, and then how do you know you're successful when you've achieved those milestones? What is your measure of success? Can never have too much documentation. Well, I shouldn't say that. You can have too much documentation, but it's a good idea to maintain good documentation. What do I mean by that? Okay, well, if we're talking about our planning and we understand where our milestones are, we got to maintain some level of documentation in terms of who's responsible for what. How do we know when they're going to be successful? What is the estimated timeline of the particular task that they're assigned? You're right. That way you have some reference information you can go back to later on. After action reviews, you can start aligning. Where did you make mistakes? Those types of things. So it's always a good idea to maintain really good documentation as to the process and everything that's involved within the process. Focus on proven methodologies. And what I mean by that is there's been a lot of companies over the last 30 years that have transitioned from 2D to 3D, right? Some companies will say, well, the first thing that we want to do is we want to, train everybody. And then at some point, we're going to start developing content. Other companies might say, well, we're only using 2D now, but in order for us to, increase profitability by 50%, we want to start automating as much as we can, right? So there's certain steps that need to be taken in order to be successful at transitioning from 2D to 3D. And if you're not adhering to those steps, if you're not focusing on those proven methodologies as to the appropriate way of getting this challenge taken care of, then you're going to be setting yourself up for failure. So really this 4-part series really kind of focuses on and shares with you what those proven methodologies really are. And at the end of it all, have fun with it. Enjoy the journey. If you're currently using 2D now and you're successful and you want to be more successful, you want to be more optimized, more efficient, you want to be able to scale and grow and expand, getting to 3D is the means that's going to get you there. That's what's going to elevate you to the point where you can start seeing these successes. So enjoy the journey. Be excited about transitioning to 3D because it's going to open up so much more opportunity after you get through this in terms of your technology maturity. Okay. So once you have your planning done in terms of who, what, where, when, and how, you've identified your program manager, one of the very first things that you're going to want to knock out, check off that list is getting your licensing taken care of, right? And this is where I encourage you to work with KETIV, because it's not as straightforward as I have 10 users, I'm going to get 10 licenses. It kind of really depends. Every company operates a little bit differently. They have different people that have different skill sets, they have different roles and different capacities. So we want to make sure that your licensing aligns with you as a company. We want to make sure it's right sized to you as a company in terms of how you operate. And it's not, like I said, it's just not as straightforward as doing a head count and then that's how many licenses you get, okay? We can provide support and mentoring. So not only give you the training that you need so you can initially start using a 3D tool like Inventor, but what about down the road? What about advanced methodologies and how to do very fringe types of activities that maybe your base package training didn't cover, right? We're here to be able to provide that support and mentoring that you otherwise wouldn't have. And then of course we have other services available as well. We have development teams on board that can do systems integration and automation. We can create custom routines. You know, we have all sorts of capabilities here at KETIV to assist you outside of just what licensing might provide you. Okay, so some of the initial things you need to be concerned about with licensing is, well, how many users do you have? Say, for instance, you might have 20 users right now, 20 AutoCAD users, but that doesn't mean that you'll need 20 seats of Inventor. Once again, it really kind of depends on what is their role and responsibility. When we think about traditional engineering staff, we have engineers, we typically have drafters, sometimes we'll have designers or design engineers in there as well, that kind of play in between. So we have different roles within engineering. And similarly, when we start using 3D design tools like Inventor, our roles and responsibilities might change as well. And what I mean by that is, just because you're using Inventor for 3D design doesn't necessarily mean that you're going to be responsible for creating the 2D documentation from those 3D designs, right? You could have people on your team that all they do is develop 3D models and they put those models together. And maybe you have more junior level users that maybe you don't want to give them that level of responsibility. So maybe once those 3D designs are produced, you have lower level individuals that are drafters that are now taking those designs and producing the 2D documentation associated to those designs. You may have people that are solely responsible for checking information. Maybe they don't need a full-blown seat of Inventor. Maybe they can use another tool to do their checking, so they don't need Inventor specifically. So understanding how many users you have and their roles and responsibilities, that's what's going to start building out that picture in terms of right-sizing your licensing to you as a company. What about your expansion goals? Say, for instance, currently you're using 2D, you want to move to 3D. By moving to 3D, now you've improved your throughput through engineering by, say, 30%. Well, now it might afford you an opportunity to start doing expansion, spinning up new R&D projects, coming out with new products, maybe getting into a different industry altogether. So once you start removing the bottleneck from engineering, you can start focusing on expansion. Focusing on your expansion might alter or adjust your needs in terms of licensing as well. So understanding what your near and long-term business objectives are in regards to your expansion goals will also help in terms of understanding your licensing. And timeliness. Case in point, companies that are transitioning from 2D to 3D, like I indicated, one of the first things they typically want to do is get their licensing and get through training. But if you haven't done your planning and you don't know exactly when those users are going to start using Inventor, what's the point in putting them through training if it's going to be 6 or 8 months before they start using the tool? Whatever they've done through training, they're going to lose that information by the time they're behind the application and using it on a regular basis to become more familiar with it. So Timeliness is extremely important too, in terms of your plan and when things will be available and when things will need to be used as well. All right. So work with KETIV. We can definitely help you out with your licensing needs in that regard. Training. Once again, come and work here, work with KETIV. We can provide you all sorts of different training opportunities, from remote training to on-site training to standard curriculum to custom training curriculum. We have teacher-led opportunities, or we have on-demand training opportunities. We partner with a company called Pinnacle that we can produce all sorts of training video, and they have a lot of training content already available, where you can jump on there and start learning at your convenience. Maybe you want to learn a little bit about creating assemblies, and then maybe a week later you want to learn a little bit more about drawings. You don't have to be, you don't have to adhere to a training curriculum. It's all at your on demand, at your disposal in terms of how you want to learn. And then, of course, like I said before, we have ongoing training and mentoring. So at any time when you want to know a little bit more around, 3D design, make sure you reach out to us. We can set something up and address your needs as necessary. All right. So when it comes to planning your training, you need to understand who will need to be trained, right? Who already has some aptitude and some knowledge around 3D design, and who doesn't. Based upon that experience level, you may even come up with a number of different training paths for your users. Those new users might have to go through everything. Maybe this is the first time they're exposed to 3D design. Whereas maybe you have more seasoned users that have used CAD applications at other companies or in college, and they have extreme familiarity with it. So gauge your users, understand their aptitude, and that will also help in terms of developing your training process. When should we conduct the training? And this is what I stated before. By creating your plan in terms of when you're going to get licensing, when you want to do training, when you want to build content, when you start using your 3D CAD application on a regular basis. All that needs to be thought out ahead of time, so that way you can plan your training appropriately. So once again, you're not training your users and then they're not using that tool for months on end, and then they've lost everything that they've learned through their training classes. So make sure that we're coordinating your training in such a way where it aligns with when you're going to roll out, so that way that training doesn't go wasted. Okay. And then how will we leverage that training provided? Meaning, if sometimes standard curriculum training isn't enough. In some cases, standard curriculum training is more than what we might need in terms of how we do things or the products in which we produce. So how will we leverage that training provided? Meaning, do you need standard training, custom training? How do you develop best practices coming out of that training? What's going to make the most impact in terms of your products coming out of that training as well? So all those things need to be looked at very closely in terms of licensing and training specifically. Okay. All right. So internal resources. I like bringing this up because I see this in a lot of different companies, and the companies that really focus on their internal resources around ongoing support internally, I find to be far more successful and far more advanced within their design processes than those that don't have internal resources. So what are some examples of some internal resources? I usually recommend to companies to develop some sort of internal user group, right? A group of individuals around design that are meeting on a regular basis, maybe once or twice a month, to talk about either new technologies, new workflows, new features, a better way of doing something than that might align more closely with what you do as a manufacturer than maybe a process that was uncovered during your training, right? So those internal user groups allow or provide some sort of platform for everybody within the company that utilizes 3D design to have a means to say something in terms of maybe where they're lacking in terms of their aptitude, or being able to share newfound knowledge around maybe some seminar they went to or something they found online. So an open forum, if you will, to allow everybody internally to be able to communicate around if they need to help, if they need help around 3D design, or if they can provide help around 3D design. It's also a really good way to start identifying your internal champions and your power users, right? Start scaling them, if you will, in terms of where are my champions, where are my new users, who might need help, who's already pretty strong. It's always good when it comes to internal resources to have leadership aware of what's going on. I found in a lot of instances where leadership doesn't know what engineering needs in terms of hardware, software, connected systems, peripherals, anything along those lines. Upper management has to must have awareness of the needs of engineering relative to 3D design, because once again, it is quite a departure from the needs of 2D design. Okay, so upper management needs to be aware of these needs as well. And then, of course, build a reference database around what you do internally in terms of processes, workflows. A good thing to go within your database might be reference information like white papers or procedures, things that emerge through the conversations that you have within your internal user groups. That way you can disseminate and share that information when new people come on board, or as new technologies get introduced. You can start gauging how those new technologies may impact everything that you've learned from having your internal user group. Okay, good way to communicate through your internal user group. Use Microsoft Teams, use Slack, use some sort of instant messaging service. That way you guys can set up different channels, share information, communicate, collaborate effectively. So having that internal resources is super important. Otherwise, you guys got to rely upon people like us, or your external resources, to fill that capacity. And we're all about teaching people how to fish here at KETIV. So, all right. So we've gone through licensing, we've gone through training, developing your internal resources, some sort of forum, so that way you can build up your aptitude internally within your company. Everything that we've been talking about thus far has been about how we're going to change, right? We're going to change tools, we're going to change process, we're going to change workflows, we're going to change all sorts of different things around engineering, from going from 2D to 3D. But the biggest thing that's going to change is our people, right? So we need to be aware of how transitioning from 2D to 3D is going to impact people. And this is where I always rely upon ADKAR. Guys, if you're not familiar with ADKAR, it's just an acronym: awareness, desire, knowledge, ability, and reinforcement. We have two zones here. The first three letters focus on the enablement zone, and then the second two letters focus on the engagement zone. So really simple, and quite honestly, very intuitive. But I like this slide because it kind of breaks it down, so that way we almost have check boxes, making sure we're doing this in terms of helping our people deal with change, right? So first thing we want to do is we want to make sure everybody's aware that a change is coming, right? We need to change, people. This is what it's going to look like, right? We need to then get a feel from everybody is what is their desire for the change? Is everybody on board? I mean, you're going to have some people that be like, I don't think we need to change whatsoever. I don't understand it. It's, this is silly. And then there's other people who are like, we needed to change, a long time ago. I can't believe this is finally happening. Whatever the case might be, we need to understand from people's perspective, Do they desire this change? What is their desire for this change? The K stands for knowledge. How do we make sure that our people have the knowledge that they need to understand this change, to deal with this change? This comes in the form of training, putting out different reference and resource information to make sure that everybody is knowledgeable of the change and why we're changing, okay? After we do that, we need to make sure that everybody has the ability to change. So are they familiar with the change that is coming? How are we monitoring the change to make sure that we're reinforcing our users so that way they don't go back to their old ways? I mean, we've seen this 100 times, right? Where we make a change, somebody doesn't quite get it, they get frustrated with it, they go back to the old way they're doing it just so they can get that job done. So we want to eliminate that from happening. So generating awareness, desire, and knowledge, and then once we've provided that information, support our users in terms of their ability and reinforcing that change so that way they don't gravitate back to some older ways of doing things. We want to move forward in a forward direction. ADKAR helps us do that. So the takeaway here is we need to be cognizant of our users and how they're dealing with change, because everybody deals with change a little bit differently. So following ADKAR will ensure from a planning and preparation perspective, we're not only just addressing the tools and the training and the licensing, but we're also dealing with the people as well. All right. So next thing that we want to focus on here is around file organization. And then you may be saying, Tom, why are we talking about file organization? We're talking about planning and preparation. And that's solely and strictly because of the amount of information that we're going to be generating within 3D versus what we're going to be generating in 2D. So 3D parametric design creates a ton more information, guys, a ton more. We have project files, we have models, we have drawings, we have neutral file formats, we have simplified files, we have tabulated files, we have specification information. So all of this data can be generated from 3D designs and 3D design tools like Inventor. So what do we do with all this data? How do we organize it? How do we structure it? In a lot of cases, guys, Windows Explorer just isn't enough. Now, I hear you. Some of you might be out there saying, no, we don't, we're fine with Windows Explorer. We have a good naming convention. We have a good folder architecture. We'll get in as we go through these next episodes. You're going to see the value and importance of having a data management application and not just relying solely on Windows Explorer. Okay. It gives us an opportunity to leverage file properties. So how many of you guys out there right now have a naming convention for your files that is very descriptive? Meaning I can go out to a folder, I can peruse through a folder architecture, and I can find a file because I can just read its file name and I know exactly what it is. Well, when you start working with 3D designs and you start working with the amount of data that I just talked about in terms of models, drawings, neutrals, simplified, naming convention can go crazy really, really fast. So another way that we can start identifying the information that we need is by leveraging properties or metadata. I talked about this before, but file properties allow us to start coordinate or categorizing, classifying information. A good file property is not only a file name, but like a material or a part number or a stock number or a description or an author. All of those are different file properties, characteristics that are associated to files. So if you start leveraging file properties more, start providing more information to your files, you don't have to be dependent upon file name exclusively when it comes to searching and finding the information that you need. So look for more around that in coming episodes, but it's important for us to understand around file organization and file properties in order for us to facilitate our searching capabilities. And when it comes to file organization as well, I've seen this a lot where a lot of companies will have a very, very, very deep folder architecture, folder structure, and transitioning from 2D to 3D because of the fact that we're going to be making different data, different file types. We have to organize it differently. We have to be cognizant of file naming conventions. This also presents an opportunity to reevaluate our folder structures as well. How are we storing this information? Are we storing it in an efficient manner? Are we storing it this way because this is just the way that we've always been doing it, right? So you need to be asking yourselves these types of questions as well, because this is a good opportunity to kind of adjust things accordingly if necessary, right? All right. I mentioned this earlier as well, file name or naming convention. I don't want to just blanket say file naming convention. This is naming conventions as a whole, right? Because with Inventor, when we're working with 3D models, we have a lot of different things that we need to name. And naming convention, having a naming convention scheme for all these different places that we have to name things, it's good to get this figured out ahead of time as opposed to after the fact, right? So when it comes to your planning and preparation, coming out with your naming conventions is going to be important too. Really, things to focus on with naming convention is unique file names. We've seen this a lot, and I'm sure you've seen it as well. I'm sure you can even do a search right now within Windows Explorer for a file name, and then even on your own system, I bet you're going to get more than one return when you do a search. Well, you have to then ask yourself which one is accurate, right? If you have 50 files in Windows on your server named the same but in different places, and everybody does a search a little differently, they're going to get different responses, and they're not going to really know which one is going to be accurate. So having unique file names, however you achieve that, is going to be of the utmost importance. And then you need to ask yourself again, well, what's in a file name anyway? We get a lot of customers that use descriptive names for their files. And then we have other customers that use a sequential arbitrary file name, because what's most important is that that file name is unique. And then they use their properties and attributes and other characteristics to delineate between the right file and another file. So file name, not so important. All those other properties are far more important in terms of identifying, locating the information in what you need. So you could use descriptive naming, not necessary, but we'll talk about that more in other episodes. Sequential arbitrary file names, once again, just start at 0 and just go in a sequential fashion. File name doesn't mean much if you're relying upon other properties and characteristics. A very common naming convention is the alphanumeric, A dash something, B dash something. Sometimes that's a good way to classify information by still using its file name, but not relying so much on some other file properties. So there's an opportunity there as well. Smart numbering, I've seen this. This is very common, where you have a file name and then each character, whatever the value of that particular character is, might mean something differently. I've seen this where, if it's a schematic, it's S dash something. If it's an architectural drawing, it's A dash something. Or, if it's a sheet metal component, it's SM dash something, right? So you can use an alphanumeric file naming, a smart numbering, sequential arbitrary file names. It really doesn't matter as long as we're really focusing on the fact that it has to be unique. That's really the most important bit about your naming conventions. When it comes to file names, right? We'll talk about other naming conventions in other episodes, but file naming convention, you can get away with a lot of different things as long as they're unique. And then, of course, you can always use Vault. One of the features inside of a data management system like Vault is there's a naming scheme functionality that's inside of Vault, where the database within Vault can manage your file names as well. So really interesting concepts in terms of how we're going to generate that information. But once again, the most important bit, it's that it's unique names. All right. Data consumption needs, meaning what data do we need from, as you know, in engineering, what information do we need from other areas in order for us to do our job? How do we currently consume data? Where does that data come from? Do we need to do it this way? Are there other ways that we can consume this data? Are there other systems we can get this information from? So all these questions need to be asked around data consumption. And then, of course, now we need to start thinking about downstream as well. What other areas within the business needs to consume data from engineering? What does that data look like? Is there other areas where they can get that data? Does it have to come from engineering? So you should entertain yourself with all these questions in terms of, you know, data consumption, so that way we can start developing our roadmap around our planning and our preparation, so we know when we're going to be doing very specific things, and of course, what shape is that going to take form, right? Other things that we need to be looking at here in terms of data consumption, what are the formats, right? This is also a very important key. Is it DWG? Is it DOC? Is it Excel? Well, what is a JPEG? What are the formats that we need to be responsible for here inside of engineering in terms of data consumption and data output as well, okay? And I mean, this is always a big one, is can engineering access and find the data that it needs in a timely manner? This is almost one of the biggest problems that engineering departments have nowadays, is how can I find the information that I need? And if I do find information, how much confidence do I have that it's accurate, right? You can ask any engineering department and they'll always have that as a problem. That's always one of their problem statements. So, you know, you need to be looking at this up front before transitioning to make sure that we're prepared and we have a plan for how can we find the information that we need in a timely manner, okay? All right, so with that, want to talk about this last bit here around metadata management, right? So we talked about naming conventions. We talked about a little bit about properties, and that's really what we're focusing on here, is how can we apply more information to our files so they're data rich? So that way I can go to one file, I can get all the information that I need. I don't have to bounce around to many different files. So the more metadata that you can apply to your files, the better off you're going to be. So you can inside of Inventor, inside of Vault, you can put as much information in your files as you want, in terms of being able to identify these files from their characteristics. It enhances your searching capability, be able to find what you need when you need it, with the assurance that it's going to be accurate. Having metadata in your files allows you to not have very complex file naming conventions, which lends itself to ensuring that you maintain unique file names. One file has one name. It makes engineering data more useful for parallel and downstream systems, right? So think about description, if you will. A lot of companies will have a very specific format for their descriptions. And if you input a description in one area, and then another user inputs description information in another area, maybe in another system, in another application, right? So if you're putting the same information in many different systems, following a different format from many different users, the chances of that information aligning and being coordinated is pretty slim, right? So by using metadata and being able to connect to other systems, you can make sure that that information is consistent from one system to the next to the next. So that way you have higher, more useful engineering data. It also allows for classification categorization. I mentioned that earlier. And it allows for better data compliancy, right? So think about data compliancy in the fact that if I have property information associated in my files, and I have to apply a value to every property. Maybe that's just part of our compliancy process. How do I ensure that the value provided aligns and meets that compliancy, right? So there's a lot of different ways that we can automate things to ensure data compliancy, but by having metadata associated with your files, it's going to be a lot easier to evaluate that information and those files to make sure that they are compliant with whatever standards and regulations you might have in place, right? And this metadata management also lends itself to IP preservation, being able to identify intellectual property in ways of low versus medium versus high security, kind of helps you in understanding that information better as well. All right. So a lot of information that we've covered so far, but all of this is very important. And the whole purpose of this, guys, the whole purpose of going through this exercise is enhancing your technology maturity, right? If we talk about technology maturity just for a moment here and looking at this level 1 on the left-hand side here, if we think about the evolution of CAD, going from the drafting board to 2D to 3D, if we think about the evolution of technology in general over the last however many years, kind of aligns with what we're talking about here around technology maturity, right? Level 1 technology maturity, you're using 2D CAD, nothing's connected, very manual processes. Whereas once you get to level 2, you're integrating some things. Maybe you're using 3D CAD. Maybe you're using a higher complexity in terms of a data management solution. Whereas now level 3, much more managed. You're connecting systems. You're using 3D CAD. You're using sim and simulation and analysis. You have an enterprise level ERP system in place. You're starting connecting those things. And in level 4, your optimized area, where now you're introducing AI and automation, and everything is kind of a well-oiled machine, if you will. And it's not very manual. So manual level 1 to not manual at all at level 4, right? What we're doing here at KETIV is helping you evolve along your technology maturity as well. And everything that we're talking about here within this series is about getting you guys to this level 3, right? How do you go from level 1 to level 3? Instituting 3D CAD is definitely the first step in doing that. All right. So in summary, it's really all about the planning, guys. Lean on us. We're here to help you here at KETIV. We've done this so many different times with so many different companies of various sizes that we've probably seen the struggles and the problems that you may be currently experiencing. So make sure you reach out to us and we can help you develop that plan as well. Do your homework. Get out there. Get on the internet. Start, talking to some of your competitors. If you have some, inside people at some of your competitors, how are they doing it? How are they succeeding? How are they failing, right? Getting as much information as you possibly can in order to make these decisions will go a long way, for sure. Make sure you're taking care of your people. Remember what I said about ADCAR. Keep them informed. Give them the resources and the ability that they need in order to accept the change of transition. And most importantly of all, listen to your people. Understand where they're coming from. Not just the pros, but the cons as well. Okay. Don't be afraid to document. I said this before. Make sure you're writing this stuff down. A lot of different ways that we can document this information. If you have an online repo that you use, or if you have a dedicated storage space that you want to put this information, go ahead and do that as well. I said that about reaching out to us here at KETIV. Go ahead and reach out to us. What we do here is, before we engage with you guys, a lot of what we do is really around understanding. We first want to understand, what are your goals? What are your needs? Where are you currently at? And how we go about doing this is by doing a business process assessment, a BPA. So reach out to us, request a BPA, let us get to know you a little bit more intimately, and then we'll be able to help you out the best way that we can. And lastly, last bullet point here is set reasonable expectations. Don't try to boil the ocean. Don't try to bite off more than you can chew. Once again, that's really what we're trying to talk about here within this planning and preparation episode, is understanding what are those expectations. What kind of goals can we set that are achievable, that we can make sure that we can guarantee success. So with that being said, if you have any questions, please feel free to reach out and ask. And right now is the opportunity for you to ask anything further around planning and preparing when going through your 2D to 3D transition. Thank you very much.